Hello everybody. In today's video, I'm going to be going over completing the square. Now, this one is very easy. I'll go over why. But the applications for completing the square is usually if you want to convert an equation or expression from a quadratic expression or trinomial expression to something of sorts of a turning point expression. So let me write it down for you, right? So when you're doing when you're dealing with a parabola in grade 11, usually you would get a formula in the form of ax squared plus bx plus c, right? And equal to y. So you could say, let's say y is equal to. But we want to convert it to turning point form, where we will have it as x minus p squared plus q, right? So clearly, where this would be the maximum or minimum value, or the vertical shift, if you will, and this will be the horizontal shift. But we're not going over parabolas in this video. We're going to be going over how to complete the square. When you want to complete the square, all we want to do is just add by 0. Now, this looks funny, hey? But this is the one most important part. This 0 can basically be anything as long as something cancels itself out, right? If you have 1 minus 1, this is equal to 0. If you have x minus x, that's also equal to 0. But in this case, for completing the square, we have a specific expression that we cancel out. And this is what it looks like. So ax squared plus bx plus c. And we are going to add by b over 2 squared. Okay. So we're going to halve the coefficient of x and square it. And then in order to make this expression true, because remember, this is an expression, not an equation. We can't just add this regularly. We need to subtract it by the exact same thing so that we get our 0. Okay, so this is just the only addition that we need to do. And when it comes to equations, you'll also see how that is applied. Okay, so let's actually just get into an example and see how this specific thing is used in actual trinomials. So our first example is to complete the square on x squared minus 6x plus 7. Now, I'm going to show you why completing the square always works and always gives you that turning point form that I showed in the beginning. Like when you have a binomial, right, but it's being squared. It's some linear function that's being squared all over, overall, and then you have like a maximum shift or minimum shift. That's usually for parabolas, okay? So let's look at the actual trinomial. It's x squared minus 6x plus 7. But we're going to do the exact same thing that we showed, right? It is going to be plus b over 2. And remember, b is represented by the coefficient of x. Meaning we're going to have negative 6 over 2. Okay. Squared. And we also need to minus it by the exact same thing. Negative 6 over 2 squared. Okay. Well, it's actually an equal sign. So now what we have is x squared minus 6x, and what we are going to do is we are going to swap, or we are going to take this thing we've added and then shift to this side, right? We want to make sure that we get a perfect square out of this, and that is why we added this part here. So I'm going to take the one with the positive sign over. And then when we actually do the factorization, I'll explain why I took that over, okay? So let's take the positive one over. So it's going to be plus, you can simplify this as negative 3 squared, by the way, or you can even write it as 9. Because remember, this whole thing is just going to be 9. And then notice that we have a trinomial, and I would recommend putting a bracket around it, protecting it from the thing that we took out. It's basically just smash and grab at this point. We're taking the 7 out and we're just going in over here. We're replacing its spot. And then we're obviously going to leave the other one outside. Remember that this is equal to 9. Okay. So we replace the 7 with this value. Now the reason why I chose the positive one and instead of the negative one was because when we want to get a perfect square, we need the signs to come out the same in the factorization. So notice, if I take the negative, and when I do the factorization and multiply by the positive, I still get a negative as an output. So this is what it's going to look like, right? When we're factorizing this, notice that x squared can be written as x times x, 9 can be written as 3 times 3, and that is why this is why it is completing the square, because now we have a perfect square that also gives us the coefficient. It always works like that. Because the perfect square of this value, but when you half it inside of the square, it'll always give you that coefficient. And it just comes down to choosing the sign, whether it's positive or negative, okay? So therefore, if we factorize it, all we're going to have is x minus 3, and then, because the biggest goes to, okay, both of them are 3, so the negative will go to one of them. And then the other one is the negative times a positive gives us a negative, okay, which is 3 for the remaining one. Now you can see, okay, and obviously we have plus 7 minus 9, which is minus 2. Now notice that these brackets are repeating itself, and it can be written as x minus 3 squared. And that is why I chose the positive one, because I want this negative to multiply by the positive when we're factorizing to give us the same sign as this. So notice, if this was a positive, then you would obviously choose the positive, because it's going to give the same sign, right? In that case. So you'd usually always pick the positive one, okay, in this instance, and this is minus 2. This is what you call the turning point form for the parabola. Okay, so now we have completed the square. Let's do another example on the expressions. Now, before we deal with equations, we need to understand what do we do whenever we have a coefficient in front of the x squared? Because usually it would be easier to work with completing the square if we just had 1 in front of the x squared. Or just factorizing in general just becomes easier if we have 1 over here, okay? So how do we counter this? So the way we can counter this is just by, this is the steps that you have to take. You have to take out the coefficient as a common factor, such that what you're going to get is 2, let's say square bracket, x squared plus 3x, because we can take it a common factor of 6, which leaves us with 3, or common factor of 2, which leaves us with 3, and then same with this one, but it's going to be minus 3. Okay, now what do we do from here? Notice we have our form that we want to complete the square for. So notice this isn't a perfect square, so we want to get a perfect square out of this, okay? So how do we do that? Inside of this bracket specifically, we need to do the manipulation. Nowhere outside, because then how are we going to get inside? Remember, we need to make sure that we start from the inside. Otherwise, it's impossible to do it from the outside. So it'll be 2 multiplied by x squared plus 3x minus 3. And then we're going to do the plus b over 2 squared, which is, the b value is 3, right? So it's going to be 3 over 2 squared minus 3 over 2 squared. Okay, then we close the bracket over here. So we've done it inside. Now we're just going to shift the positive one around with the negative 3. Okay, so then what we have is 2 multiplied by x squared plus 3x, and then it's going to be plus 3 over 2 squared. Okay, and this is going to be minus 3 minus 3 over 2 squared. Alright, now what makes this special? Notice that we have a trinomial here, and we can factorize this. X squared can be broken up into x and x, and then 3 over 2, which is 1 over 5, right, can be broken up as 1 over 5 and 1 over 5, right? And notice that 1.5. Notice that 1.5 plus 1.5 gives us 3, right? If we do the factorization method. So that actually works in our favor here. And that is why we halve the coefficient and square it, so that we're able to at least add them together into our coefficient, or subtract them together into our coefficient. So then what we're going to do is we're going to factorize that purple bracket, and then obviously you know it's going to be a perfect square. So notice it's just going to be x. The positive signs repeat itself, so it's going to be plus 1.5 repeats itself, so it's just going to be 3 over 2, because 1.5 is 3 over 2. But leave it as a fraction, and this is all going to be squared. You'll notice you'll get to this point. Then you're going to have minus 3 on the outside, and then minus 3 over 2 squared, which is obviously just minus 9 over 4, using our laws of exponents, where we can take the square into both the numerator and the denominator. Okay. And then we can simplify it. It's 2 into x plus 3 over 2 squared. And this is just going to be minus 3 minus 9 over 4. It's just going to be the same as if you just do like the fraction stuff, I guess. If you know how to deal with fractions, this will be minus 12 minus 9 over 4. Okay. Or you can use a calculator if you want to. All I did was I just said 3 is the same as negative 12 over 4. Then I said that the denominators are the same, so I wrote them into the same fraction. Okay, that's what I did. Then we'll have x plus 3 over 2 squared. And then we simplify the numerator. Minus 12 minus 9 is just the same as minus 21 over 4. Okay, and if you want to take the 2 in, you can also do that. But otherwise, this is your turning point form. Okay, and now we've completed the square. Now let's get to the last example. So for our last example, we are going to be dealing with an equation. So we need to solve for x if blah blah blah, right? All of this. Okay, I'm joking. I'm going to say 3x squared minus 15x minus 21 equals 0. First things first, notice that we have a common factor. Let's get rid of the common factor. Okay, 3 is the common factor. Now we have x squared minus what is left over from here, from the 15, it's 5. Because 15 divided by 3 is just 5, minus 21 divided by 3, which is just 7. Okay. So this is equal to 0. And the best part about having equations which is equal to 0 is that we are actually able to divide both sides by 3. So we can just divide both sides by 3 and we can just get rid of the 3. That's the best part of having equations, and we don't have to be stuck with them. I mean, yeah, exactly. We don't have to be stuck with the common factors or the coefficient stuff. Okay, so if we divide both sides by 3, we're gonna have x squared minus 5x, by the way, minus 7 is equal to 0 over 3, which is 0. Okay. Now remember, in the last ones we kept telling these constants to move aside whenever we completed the square, right? So that we can have a new constant. So we're going to do the exact same thing. We're just going to tell the constant right now, step aside, buddy, and then it goes this way. Okay, so it goes over to the other side. I feel like we need to like have a petition just to free this like constant, man. When it comes to completing the square, we always have to just push it out of the way. I think this is mathematically bullying constants right now. We are going deep into the source right now. Okay, let's stop. We need to complete the square now, okay? X squared minus 5x, and then we're going to add, remember what to do? It's going to be b over 2 squared. So it's going to be negative 5 over 2 squared, because b is negative 5, the coefficient of x. Then we're going to minus it by the exact same thing, negative 5 over 2 squared, which is equal to 7, right? And then remember, we're going to take the positive one with it. So it's just going to be x squared minus 5x, and then we're going to add negative 5 over 2 squared. And then let's take this other one over so that we have it equal to 7 plus negative 5 over 2 all squared is basically just going to be 25 over 4. Okay. Now from here, negative 5 over 2 is just going to be what we have over here, right? notice that when we have negative 5 over 2, which is the same as negative 2.5, and we also have negative 2.5, if we add them together, we're going to get negative 5, okay? So therefore, it actually works out perfectly. And we'll have x, and notice the first sign is negative, so meaning the whole thing should be negative because it's going to cancel with a positive. So it's going to be x minus 5 over 2, okay? And then we're going to square it because we factorized it, we completed the square. And this is just going to be equal to 7 plus blah, blah, blah. The 7, in order to get the denominator of 4 here, we need to multiply 7 by 4. And then we divide the thing by 4 as well. So 7 times 4 is just going to be equal to 28. Okay, so 28 over 4 plus 25 over 4 is just going to be the same thing as 28 plus 25, which should give us a value of 53. So 53 over 4. And it's going to be x minus 5 over 2. So all we need to do, in order to get rid of the square, we need to take the square root on both sides and then plus minus. Okay. So therefore our answer is just going to be x minus 5 over 2, which is equal to plus or minus the square root of 53 over 4. And then if we take this negative 5 over 2 to the other side, what we are going to have is x is equal to 5 over 2 plus or minus the square root of 53 over 2. Because notice that we have the square root of 4 at the bottom and the square root of 53 on the top. And then we can obviously just simplify it further, obviously, as a final answer and say x is equal to 5 plus or minus the square root of 53 over 2. Okay, so we didn't even have to use the quadratic formula to get to this point. All we did was complete the square, and we just got this value. So that is how we can get to these values without actually using the quadratic formula. And completing the square is actually the best way to do it without a calculator. So yeah, that is how you complete the square using expressions as well as equations.